The International Space Station recorded something on July 3rd, 2025, that stopped scientists cold. Not a glitch, not a camera error, not a bird or a balloon or a piece of debris. NASA astronaut Nicole Ayers was looking out of the window over northern Mexico in the southwestern United States, and she pointed her camera at a thunderstorm below her. What appeared in that image was not what she expected. Lightning was moving in the wrong direction, not downward toward the ground, the way every human being who has ever stood in a storm expects lightning to move. It was moving upward, away from the storm, straight toward space. A massive branching column of red, white, and blue light shooting from the top of a thundercloud toward the edge of the atmosphere and beyond. Ayers shared the image the same day, and it collected over 2.7 million views within hours. And the more scientists looked at it, the more they realized that what they were looking at was not just rare. It was one of the least understood phenomena Earth produces. And the fact that it took humanity until 2025 to get a clear photograph of one from directly above tells you something important about how much of our own planet we still do not understand. That image became one of the most discussed scientific photographs of 2025. But it was only the beginning. Because when you pull back and look at everything the ISS has been recording above the Earth in 2025 and into 2026, a picture starts to form of a planet that is doing things above our heads that science is still in the very early stages of explaining. And when you add to that the extraordinary events of 2026, a year in which the United States government publicly admitted, through its NASA administrator, that the space agency holds imagery of objects in space that it cannot identify and cannot explain, the question of what is happening in the space above our world stops being a fringe conversation and becomes something that serious scientists, military officials, and government agencies around the world are now openly treating as one of the most important unresolved questions in modern science. This script is not speculation. Every single thing in it is confirmed, documented, and sourced. So stay with it to the end, because the full picture is more interesting than any single piece of it. Start with the gigantic jet. Because to understand why that July 2025 image mattered so much, you need to understand how little we actually knew about it. The phenomenon Nicole Ayers photographed belongs to a family of events that scientists call transient luminous events, or TLEs. This family includes red sprites, blue jets, elves, and gigantic jets. The names are almost whimsical, but the phenomena are not. They are real, measurable, high-energy electrical discharges that occur in the upper atmosphere, tens of miles above the cloud tops where conventional lightning lives. Pilots began reporting them for decades before science officially confirmed they existed. Strange flashes above storm clouds, lights moving in the wrong direction, glows at altitudes where nothing was supposed to be happening. For a long time, these reports were dismissed. It was not until 1989 that scientists got the first confirmed photographic evidence that these events were real. That means a whole category of atmospheric electrical phenomena that Earth has been producing continuously for its entire existence was not even confirmed scientifically until 35 years ago. Think about that. We live on this planet. We study it constantly, and we had no confirmed record of events happening routinely in our own atmosphere for the entire span of recorded human history. Red sprites appear in the mesosphere, roughly 50 miles above Earth's surface. They shoot upward from the tops of thunderclouds, not downward toward the ground. They flash for so little time that the human eye can barely catch them at all. Each individual sprite lasts around 10 milliseconds. They look, in photographs, like enormous upside-down jellyfish of red light hanging in the darkness above the storm. Blue jets are different. They are more focused, more intense, erupting from the very top of a thunderstorm as a narrow cone of blue light and reaching up to around 25 miles altitude before fading. Elves are something else entirely. The name stands for emission of light and very low-frequency perturbations due to electromagnetic pulse sources, and they appear as an expanding ring of ultraviolet light near the bottom of the ionosphere. An ELVES event can spread hundreds of miles in under a millisecond. A single ELVES ring can pump enough electromagnetic energy into the ionosphere to affect radio wave propagation across a wide region, meaning these events, happening above thunderstorms, can affect the way signals travel around the entire planet. And then there are gigantic jets, the rarest of the family, the ones that go the furthest. A gigantic jet does not merely reach into the mesosphere. It breaks through. It forms an electrical bridge between the top of a thundercloud at around 12 miles altitude and the upper atmosphere at around 62 miles altitude. It deposits a significant charge directly into the ionosphere. NASA describes it as direct electrical contact between the bottom and the top of what we normally think of as our atmospheric system. And on July 3rd, 2025, Nicole Ayers photographed one from 250 miles directly above it from a vantage point that gave scientists something they had never had before. A clear, high-resolution image of a gigantic jet taken from above, looking down at the event as it happened, showing its full structure from the cloud top all the way to the ionosphere in a single frame. Dr. Burku Kosar, the principal investigator of NASA's Spectacular Citizen Science Project, which collects images of exactly these kinds of events from observers around the world, confirmed the identification. She said the image gave researchers a rare and spectacular view of something that is typically caught only by accident from the ground when a camera happens to be pointed at the right storm at the right instant. NASA officially published and highlighted the image multiple times, most recently drawing fresh attention to it in April 2026. And in the process, the agency was honest about something that does not appear often in official press releases. The nature of gigantic jets, how exactly they form, why they escape the storm when ordinary lightning does not, and how they interact with the layers of the atmosphere they pass through, remain active topics of research with no settled answers. Scientists know these events happen. They have the photographs. They have the sensor readings from instruments mounted on the ISS. The Atmosphere-Space Interactions Monitor, or ASIM, mounted on the outside of the station, records gamma-ray flashes and high-speed optical data from these events continuously. And what that data is showing is that transient luminous events are doing more than producing a light show. They are injecting energy and electrical charge into the ionosphere, a layer of charged particles that radio communications, GPS signals, and long-distance navigation systems depend on. They are altering the chemistry of the upper atmosphere in ways that researchers believe may feed into greenhouse gas levels. They may be producing measurable amounts of nitrous oxide and ozone-affecting compounds with every discharge. The full scale of what these events are doing to the planet's atmospheric chemistry is not known. And here's the thing that makes this more than just an atmospheric science story. The ISS is the reason we know as much as we do about these phenomena. Because the station orbits at 400 kilometers altitude, it is above the clouds, above the storms, looking down at the tops of the phenomena that ground-based observers can never see clearly. It is in the ideal position to watch the atmosphere from the outside in. And what it has been recording, especially since 2025, is showing scientists that the electrical behavior of Earth's upper atmosphere is far more complex, far more energetic, and far less understood than any textbook written before the space station era would suggest. A planet that has been studied continuously for centuries is still producing phenomena that we only discovered 3 decades ago and still cannot fully explain. But the story does not stop in the upper atmosphere, because 2025 and especially 2026 have added a second layer to what the ISS and surrounding space infrastructure has been recording. And this layer involves something that the United States government has now officially and publicly acknowledged it cannot explain. In May 2026, the Trump administration launched what it called the Presidential Unsealing and Reporting System for UAP Encounters, or PURSUE. On May 8, 2026, the Department of War published the first tranche of declassified files containing 117 documents, 29 sensor videos, and 14 photographs spanning 1944 to 2026. Secretary of War Pete Hegseth described the goal as maximum transparency. By July 10, 2026, a fourth tranche had been released, and the files now include ISS-related material, NASA mission recordings, and footage from military sensors that the government openly says remain unresolved. These are not old files that researchers dusted off from a storage room. The most recently dated video in the first release, described as captured by a Department of the Army sensor, shows infrared tracking of an aerial object that ARO, the All-Domain Anomaly Resolution Office, has not been able to identify. That video was captured in 2026. The fourth tranche specifically includes footage from NASA's 1996 Space Shuttle Columbia mission, STS-80, that had never been publicly released before. Astronaut transcripts from Apollo and Gemini-era missions are in the files, including audio from Apollo 12, in which crew members describe unexplained light phenomena during the mission. Scott Carpenter, during the Mercury Atlas 7 mission in 1962, described reflective white particles that moved at random, looked exactly like snowflakes, and moved faster than his spacecraft. These are not claims from anonymous internet sources. They are official government records now publicly available on a government website called war.gov. And in June 2026, NASA Administrator Jared Isaacman confirmed publicly and directly that NASA holds imagery of objects that cannot be explained. He said it clearly. The data cannot be explained. He said the government had kept information buried in files, and the president directed agencies to release it. He said more big file releases from intelligence agencies are coming. About 40% of UAP cases reviewed by ARO in 2026 lack clear human explanations, according to the agency's own reporting. None of this proves any specific conclusion. Isaacman was clear that no confirmed evidence of extraterrestrial life or non-human technology has been found in the released files. ARO consistently notes that the majority of UAP cases resolve to conventional explanations: drones, balloons, weather phenomena, sensor artifacts. The honest version of this story holds both facts at the same time. Most UAP sightings have ordinary explanations, and a meaningful portion documented in official government records, reviewed by trained military and scientific personnel, with sensor data attached, do not. The gap between those two facts is where serious scientific attention now sits, and it sits there openly, publicly, for the first time in the history of this subject. In November 2025, the ISS marked 25 years of continuous crewed operations, a milestone no other human spaceflight program has reached. In those 25 years, the station has operated as a scientific platform, a laboratory, an observatory, and increasingly as a witness to phenomena above the Earth and around the Earth that our science is still catching up to. The ASIM instrument has cataloged thousands of transient luminous events. The cameras have recorded fast-moving objects passing near the Earth's limb that NASA's own public communications acknowledge prompt legitimate questions. In November 2025, viewers watching the ISS live stream reported a luminous object crossing the frame before the feed briefly switched to a signal loss screen. NASA's consistent explanation for these feed interruptions is that they are automatic, triggered by relay satellite handoffs that happen many times a day. The cameras are automated systems, and the feed cuts during coverage gaps. That is the official and technically accurate explanation for how the video system works, and it is also true that the question of what the objects in some of those frames are remains, in specific documented cases, unanswered. The ISS crew members themselves are scientists and highly trained professionals. Nicole Ayers, who captured the gigantic jet image, is a U.S. Air Force lieutenant colonel and combat-experienced fighter pilot. She was part of the SpaceX Crew 10 mission launched in March 2025, returned to Earth in August 2025. She did not speculate about what she had photographed. She shared the image, identified what she thought it was initially, and let the science teams on the ground work through what the data showed. That is how the process is supposed to work. And the conclusion the process reached was that she had photographed one of the rarest electrical events our planet produces, an event that only 25 years ago, science did not even have a confirmed photograph of, at a moment and from a position that gave researchers the clearest look at its full structure that anyone had ever obtained. That single fact is worth sitting with carefully, because it represents something that gets lost in the more dramatic parts of this story. A phenomenon that Earth has been producing for as long as thunderstorms have existed was confirmed by science only in 1989, photographed with full structure from the ideal vantage point only in 2025. What else is happening in the space between the cloud tops and the edge of the atmosphere that we have not confirmed yet? What does the 25-year record from the ISS contain that has not been fully processed? The data archive from the station's instruments is vast. The ASIM sensor alone has captured thousands of events. Researchers are still working through what the patterns in that data mean for atmospheric chemistry, for ionospheric behavior, for communication systems, and for the understanding of how energy moves through the layers of the system that surrounds our planet. And now, in 2026, alongside all of that, the government of the United States is releasing files that document objects moving near military assets and near space platforms in ways that trained observers and advanced sensor systems cannot explain, and saying publicly that it does not know what they are. The two stories, the atmospheric phenomena and the unidentified objects, are not necessarily the same story. They may be entirely separate. Red sprites and gigantic jets are well understood as atmospheric electrical events, not as anything else. But they share a common thread. They both point to the same conclusion. The space immediately above Earth, the region that the ISS occupies and observes, is a place where things happen that science has not yet fully mapped, documented, or explained. The station has been the most important instrument for seeing that space clearly. And what it keeps showing us is that the atmosphere of our planet, the environment that every living thing on Earth exists within, is more dynamic, more energetic, and more full of phenomena that defy simple explanation than we understood before we put people up there to look. The image from July 3rd, 2025 sits in NASA's official archive. The government files are publicly available on WarGov. The ASIM data continues to come in. The ISS continues to orbit, passing over the planet 16 times every day, its cameras watching the cloud tops and the atmosphere and the space around it. And the scientific papers continue to note, carefully, professionally, in the measured language of peer-reviewed research, that the nature of these phenomena, how they form, how they interact with the systems around them, and what their full implications are for the planet below, remain active topics of research without settled answers. That is not a dramatic statement. It is just a true one. And sometimes the true ones are the ones worth paying the most attention to. The ISS is still up there right now, still recording, still watching, still sending back data that researchers are still working to understand. Whatever it records next, one thing is already certain from what it has given us so far. The world above the clouds is stranger, larger, and less explained than we were taught. and we now have eyes up there that are finally good enough to see it clearly.